In this lecture, I am going to consider an example problem for power spectral density. Consider a random process, capital X of t is equal to a naught cos of omega naught t plus capital theta, big theta. Okay, so where a naught and omega naught are real constants, and theta is a random variable uniformly distributed on the interval 0, pi by 2. Find the average power p sub xx in random process x of t. So solution. Now given the random process x of t is equal to a sub 0 cos of omega naught t plus theta. Now this is constant and this also constant. Generally we know that for random variables we use a capital letter, that's why I put a big theta here. If we use small theta, then it's not a random variable. So whenever we say random variable, then we should use capital letters. Fine. Now average power that I derived the formula for this in the last lecture, which is going to be limit t goes to infinity 1 over 2t integral of expected value of x squared of t times dt, and do the integration from minus t to plus t. So this is the formula. Now in order to evaluate this pxx, first let us find this guy. Okay, so expected value of x squared of t, which is expected value of x of t times, okay, it's x of t, you can just leave it, no need to expand this. Straight away substitute the x of t value, which is a0 cos of omega naught t plus theta whole squared. So this you can expand, a naught squared cos squared theta, you can again simplify that, that is 1 plus cos of 2 omega naught t plus 2 times theta whole divided by 2. And where a naught square is constant and 2 is constant, so take the expectation inside, it is a linear operation. So this is going to be, anyway I'll write one more step, a naught square by 2 plus a naught square times cos of 2 omega naught t plus 2 theta by 2. Now it's a linear operation, expectation. So and a naught is constant, so a naught square by 2 plus this a naught square also constant, you can pull out of the integration here cos of 2 omega naught t plus 2 theta. Now this we need to simplify. So we know the formula, like expected value of x is equal to x times fx of x times dx. Same formula you can use it here, but the random variable is theta here. So we need to find out f theta of theta. So how do you find out this? In the problem it is given that theta is uniformly distributed between 0 and pi by 2. That means it is like this. This is small theta and this is function f theta of theta. So we know that the area should be equal to 1. So the width is pi by 2 and the height should be 1 over pi by 2, that's all. Therefore f theta of theta is equal to 1 over pi by 2, that is 2 by pi. So f theta of theta is equal to 2 over pi in the range 0 less than or equal to small theta less than or equal to pi by 2, 0 otherwise. So this is my density function. So the same thing you can apply here. this one. So it is a naught square by 2 plus a naught square by 2 integral of that expectation of that cos 2 omega naught t plus 2 theta can be written as cos of 2 omega naught t plus 2 theta times f theta of theta into d theta. So a naught square by 2 plus a naught square by 2 times integral of f theta is 2 by pi. It is a constant, you can pull out of the integration. This is 2 omega naught t plus 2 theta times d theta, and this is now straightforward. It's a simple algebraic expansion, and the limit is from 0 to pi by 2. This also 0 to pi by 2. So a naught square by 2 plus a naught square by 2 times, if you carry out this integration, let me write down the final result. It is going to be 2 by pi, let me write down the final result, pi times sine of 2 omega t. So this is e of x squared of t. By looking at this function, you can say that it is a time dependent function because there is a time parameter. See, there is a t here. So this function is not WSS. It is not a void sense stationary random process. Okay, because the time average of the above expression is this one. And Pxx is equal to time average of this guy, expected value of x square of t. So time average equal to limit t goes to infinity 1 over 2t integral of minus t2 plus t dt. Substitute that value here. Limit t goes to infinity 1 over 2t integral minus t2 plus t, and this one is a naught square by 2 minus, I'm sorry, this is minus, actually I did a mistake, that one is minus and by 2, a naught square by 2 sine of 2 omega t, and do the integration with respect to dt. So limit t goes to infinity 1 over 2t, this is a naught square t by 2 minus a naught square by 2, sine becomes minus cos if you do the integration, so it becomes plus cos of 2 omega t and divided by 2 omega, and the limit is minus t2 plus t. Substitute the limit and do the simplification. One over 2t. Finally, you will end up with a naught square t by 2 plus a naught square over 4 omega cos of 2 omega capital T plus a naught square t by 2 minus a naught square by 4 omega times cos of 2 omega t, and this and that will get cancelled. So limit t goes to infinity 1 over 2t. So a naught square t by 2 plus a naught square t by 2 is a naught square t, and t and t will get cancelled, this and that. this is a naught square by 2, so there is no times here, so the limit will go away, a naught square by 2. So this is the average power of the given random process x of t, where theta is uniformly distributed between 0 and pi. Okay, so pxx average power equal to a naught square over by 2. That's it. Okay, thank you.